Hello. Last talk of the day, so I'll try and bring something a little bit amusing to finish the conference for you. Maybe amusing for you, it was less amusing for us maybe at the time. Show of hands, who's broken something on production? Yeah, most people. Maybe those of you that didn't raise your hands, you forgot about the time that you took all the servers off the load balancer at once, or took down all the unhealthy instances and all the healthy instances instead of the healthy ones. Or maybe you changed some CSS in the header, which broke the footer. Breaking stuff is a natural part of the development process, and innovation often comes from failure. Autonomy and speed outweigh the weeks of QA process. So as just said, I'm Gareth. I'm an engineering manager at The Guardian. I probably have a different background to a lot of people here coming from the client side, but I wanted to tell you about some of our experiences of what we broke at The Guardian and what that taught us. So The Guardian was established in 1821. We're probably known for some investigations like Edward Snowden, Panama Papers, more recently Cambridge Analytica. We get about 10, 11 million page views a day on average. And we have three main editions, the UK, the Australian, and the US edition. For a lot of you, I'll probably be preaching to the choir, but here's a little bit about how we work at The Guardian. We have around 70 to 80 full-time engineers. We don't have any manual QA testers. Our QA team is focused more on the SETI role, our software engineering tools and infrastructure. We also don't have any separate DevOps teams. We build those skills and that knowledge within the teams, and developers are responsible for the entire pipeline. We follow some principles when we're developing. We design for failure. We design for fast feedback with preferably real users in production. We design for simplicity, and software and infrastructure are not discrete concerns. The best design includes both. We design to be monitored, so we measure everything and make that visible. We design for horizontal scaling, and we avoid state where possible. So we moved from around 11 deployments of the website in 2011 to 24,000 in 2014 when we moved to continuous deployment properly. And then last year, 2017, we had around 300,000 deployments of the website. Now you know who we are and how we work. I'm going to give you a few examples of how we screwed up at The Guardian. So a new developer asked the question, how do I test my changes? He was told, just publish an article in Composer, our content management system. He said, okay. So he went ahead and he published that article, and what was failed to mention was to use the test environment. And voila, there's an article in the poke with a screenshot of this Apple News article. Who can guess what's underneath the blackout? Anyone? That's his name. So if you're going to do something like this, then, sign your work. This could have been caught with a bit better communication, so put it out on a code environment in the test environment. In this next example, we were getting some complaints from our users who were opening new tabs, and they were immediately closing. This was a bit confusing for everyone. We'd recently gone for a module conversion to ES6. This was the fix, literally this. So this was forgotten, and the close function call was bubbling up to the window and immediately closing new tabs. Probably could have caught this one with a bit of linting. Finally, we had this file that we thought was documentation. It looks a bit like Markdown. Does anyone know what this is? It's a browser list file. Maybe someone said it over there. It's actually configuration for a tool called Auto Prefixer. Auto Prefixer prefixes your CSS with various rules. And because it was assumed to be documentation, it was immediately deleted because we had that information elsewhere. But Auto Prefixer then no longer prefix Flexbox for Safari. And what happens when you don't prefix Flexbox for Safari is your home page goes a bit long. So make config look like config. We could have added a comment to the top of that file. Your comments are communication to future developers. So we've had a bit of a laugh at the Guardian. Let me tell you about what these errors and many of the others that we've had at the Guardian taught us. Most of us will recognise this quote, "Move fast and break things." It's probably not aged too well, especially from a talk from the Guardian with recent revelations with Facebook. But the Guardian has a deployment and development process, like probably many of you here. We build and we test locally. We have pre-push hooks for linting and JavaScript tests. And when we're ready, we open smallest possible PRs. Our pull requests build in Team City. We run Scala and JavaScript unit tests. And then we require one approval from the team to merge. Team City then builds a master branch, and we use our homegrown deployment tool, Riffraff, to continuously deploy immediately to production. We have an AWS infrastructure, we have Fastly CDN in front, and we have CloudWatch logs watching our back. A note here, it took us a long time to get to the point where we just deployed immediately to master. I think we were running since 2014, and it was only last year that we took that step to go from merge to production automatically without a code environment and check in between, or staging environment check. Door to door, we're 14 minutes from merge to production. It builds in 9 minutes and deploys in 4. And once we're live, we can watch our error rates and alerts, and we can dig around in logs if needed. Just as important, maybe even more so, is that we're able to roll back to a previous version in 3.5 minutes. The important thing to understand here is that every developer is responsible for merging and deploying their code. They're responsible for watching it out to production, and they're responsible for checking that it works on the live site. Autonomy is important to ensure that you have empowered teams that can move quickly. And responsibility is important for us to learn from the mistakes that we make. So I think there's 4 main pillars of working in a stable and resilient continuous deployment environment, while making sure that we break things early and rarely, and giving the teams the responsibility and autonomy that they need to move quickly. These are pre-merge monitoring and testing, post-deploy monitoring, making smart and reliable tools, and last but not least is communication. So I'm sure we all have 100% unit test code coverage, right? We all double-check our changes locally before merging, and we have total confidence in every line of code that we write. But sometimes things slip through. I'm going to talk a little bit about one of my own mistakes. I was adding some documentation, and we decided to add a to-do to the code base, which is one of those things that you definitely come back to. It was a simple enough task, whack in a comment, push documentation. There was no code changes, so no worries. It turns out that HTML comments are different than Scala comments, and we ended up with this beauty right at the top of our AMP pages. That was there overnight, and it wasn't until someone tweeted us in the morning at Guardian Developers that we realized that it was there. It was a simple mistake with slightly embarrassing consequences. Can anyone tell why this is even stupider than initially thought? Yeah. It's not the apostrophe, it's not a grammar error, it's the fact that this is a CSS comment and it's not even an HTML comment. I was pairing on this with another developer as well, so both of us missed this. So it happens to the best of us. On flow.org, this is a to-do that pops up when you go to their homepage once. So what did we learn, or what did I specifically learn from this mistake? Well, make sure you test even the smallest of changes. But with a site the size of the Guardian, how do we have the confidence that the changes that we're making have not affected the multiple page templates or platforms that we have? Well, we build all of our pull request branches, and we run our tests before merge as usual. But we thought, how about we deploy those builds so that we can do more exciting testing? So exactly what one of our setties, Matt, did. All of our pull requests spin up an instance of our environment, and they deploy the build of that branch to the instance. What exactly has this allowed us to do? Well, instead of a manual visual check of all of our page templates, we're able to take automatic screenshots of the pull request branch. This gives us far quicker confirmation that nothing has gone awry in all of our page templates and at different responsive sizes. Developers can also run this on local hosts, so even before they push the changes, they can do a quick manual QA from the automatic testing. We check to make sure our Lighthouse performance doesn't degrade. And we can check for simple accessibility mishaps, perform microdata validation, and report JavaScript exceptions. These are simple, low-fidelity tests, but they give us a confidence that we're not breaking things. Along with the linting and the tests, these PR environments have opened up opportunities for real browser testing. This is closer to testing what the user sees and closer to measuring symptoms and not causes. This methodology is the same as we approach to monitoring our production environments. This paper by Rob Ewershuk, who is a site reliability engineer at Google, states that when alerting, we should include cause-based information in symptoms-based pages or on dashboards. We should avoid directly alerting on causes. What does this mean? Well, our users don't care about the causes of problems like databases being down or data being dropped along the way or endpoints being inaccessible. They do care about errors or slow pages or pages that never return. They care that when they change something in one place that they see that change elsewhere, and they care if features are working. These symptoms-based metrics are reflected in our dashboard. If an alert is fired, we'll often make our dashboards the first point of call. Here we can see for each application the error response rates. We can see latency, successful requests, and more. And then from these dashboards on the front end, we know which service to go to next. For example, if our article service is playing up in front end, we can check our content API. If our discussion or commenting service is showing problems, we can check the discussion API dashboard. And if the front, so the home page or our arts page landing page is showing issues, then we head over to the front's API dashboard. Each service has similar metrics dashboards to aid that initial investigation. So in general deployment, we ask that developers follow a change out to production, and then they check it on the live site. To ensure that a developer remembers to check their changes, because 14 minutes can be a long time, we use an open source tool built by Guardian developer Roberto. It's called Prout. It'll comment on a PR if a change is slow to go out, and then it will comment again when a change is on live. The Prout comment has a reminder on front end to check the live site and to have a look at the deploy dashboard in Kibana. Kibana is part of the Elk stack. This is the acronym for 3 open source projects, Elasticsearch, Logstash, and Kibana. We use Elasticsearch widely across the Guardian for analytics tools and content APIs, so the Elk stack for logging is a great fit for us. We send logs from pretty much everywhere we can, applications, CDN. We even send logs from the client side into the Elk stack. And we've recently moved to a centralized Elk stack for the logs of all of our applications. So our editorial tools, content API, the website, the apps. We're moving everything into a centralized stack, which is much cheaper, but also allows us to create multi-app dashboards. Our deployment dashboard looks like this. It shows engineers the error codes, latency, and stands as a sanity check that nothing major has gone wrong on a deployment. We love graphs at The Guardian, and I'm going to talk about communication in a bit, but something that graphs give you is a real shared understanding of what's going on in a system. We'll graph and we'll create dashboards as often as we can for anything that we can. For example, here we're measuring the API round trips for endpoints to identify long requests or any unusual patterns. And here we're graphing our Postgres auto-vacuuming process. But take a note of the thresholds. Make sure that graphs have context and meaning. Here the context is the thresholds. Without those blue lines, it's hard to understand what we're trying to show or when something might be going wrong. I'm going to contradict myself slightly here. I was talking to a lead developer, Simon, recently, and we discussed the idea that Elk may not be the best tool for the analysis and charting of metrics as opposed to string-based logs. Kibana does a pretty good job of this, but there are solutions specifically out there for metrics logs analysis. So I'd love for you to come talk to me after or drop me an email if you've got some ideas around that. Another place we love a graph is for our front-end metrics. Our users' experience rely on how our site performs, so it's important for us to track front-end metrics. So we track things like load times or time to interactive. We want to make sure that our deployment hasn't caused a major issue, and also that our site doesn't decrease in performance over time. We use SpeedCurve. It's a tool for measuring browser performance metrics built on top of web page test. And it runs a test periodically and after every deployment. So the lines here are each deployment, and you can see where the weekends are. If we've broken our budgets for metrics such as time to first paint or start render or some of our custom metrics, then we're alerted to a problem in chat or email. We've also experimented with tools like Calibre, which is similar to SpeedCurve, but it has a nice feature that sends time screenshots of page loads. That's to your email. We also use Google Analytics performance events for real user monitoring. We can aggregate the page load times and the custom metrics, such as when our JavaScript bundles are requested and how long they take to pass for real users. This allows us to monitor changes and drill down into particular browsers or devices to investigate bottlenecks and show where there might be things that are unusual there. As every developer knows, undefined in JavaScript will happily take down your application. It doesn't care about you, and it doesn't care about your users. We learned that early on at Guardian, and we made sure that JavaScript was fairly well sandboxed. This is a simple tip, but we wrap our modules and bootstraps in exception-catching wrappers, and we ensure that if we do something wrong, it only takes out the functionality of that specific module. It looks a bit like this. Fairly simply, it passes a function to a try-catch, and if the catch returns an error, we log it out to our logging service with the name of the module. The service that we use is called Sentry, and Sentry is a tool that aggregates and reports JavaScript errors. It gives us another avenue of real user monitoring, but from the point of view of things being broken. With our recent conversion of the code-based ES6, we integrated Flow into our environment. It gives us a level of type safety and hopefully removes many of the undefined and other JavaScript errors. Finally, our editorial tools team has a separate type of QA monitoring with a tool that they call ProdMon, which surprisingly is short for production monitoring. It's a synthetic monitoring application using Chrome WebDriver under the hood. So, quick show of hands, who's used synthetic or active proactive monitoring before? Yeah, a couple of people. In short, we use the test to test each stage of the user flow, and it doesn't progress into a previous step as passed. Synthetic monitoring takes more work than other testing. You have to have special users. If you've got loggings, you have to create hidden content. So for us, we have to remove it from our top 10 lists. We have to make sure it doesn't go into analytics or appear in Google search. It can be flaky, so you have to build in levels of tolerance that make sense for you and your product. What it gives us, though, is a confidence that our journalists will be able to publish and take down content 24 hours a day, 7 days a week. Our example here is a specific user flow is the creation and publication of an article in Composer, our content management system, testing that the article has then appeared in our content API and then appears on the live site. The article is then taken down, and it's tested that it's not available at each step again. This type of monitoring works great for our editorial tools and is a great approach for running periodic tests on production, both in our user flows and in the tools that we build. It also works well for testing the tasks that users don't often use, making sure they continue to work when you really need them in that critical moment. For example, taking down content doesn't happen very often, but it can be a massive problem if we can't do it when we need to. For us, knowing that our Happy Path publishing process has been A-OK for 36, this was actually yesterday, so 37 days now, makes us very happy. Which leads me on to the next point. Making sure your tooling is resilient and reliable is paramount to stability in your platform. especially when those tools have the ability to be more damaging than a user expects them to be. So another story, in March last year we had a bad deploy. Things went wrong and we started serving 500s from our origin servers for every single page on the Guardian. Seems pretty end of world scenario, right? Everyone panicking. Thankfully not. Thanks to our CDN, which is set up to serve stale, from the CDN cache if the origin servers are erroring. This serve stale approach is a lesson in itself, and it's often saved us from third party or our own poorly origins. And it's a good pattern to give you a safety net when something breaks. But this lesson is about reliable tooling. And a tool that our central production team often use is this cache clear tool. Because our homepage was failing to update, thanks to serving stale, avoiding to show our users a 500 error, it was deemed that there was a cache issue. That cache issue suddenly became a 500 issue when the stale homepage was cleared from our CDN cache. Our tools that were very reliable in clearing the cache were too dutiful in their job, and they undermined that reliability by failing at a crucial time. This taught us the value of making sure our tools not only do their 99% of the time job, but also remember the 1% critical situation role. We learned to build checks into our tools to avoid destructive behavior. The cache clear tool, for example, will now hit the origin servers, and it will only allow clearing the page from the CDN if it receives a 200. But how else could that cache clear error have been avoided? A message in chat from either the developers looking at the issue or our central production team that cleared the page could have saved us the panic of showing 500s to users. You can have the smartest tools in the world, but if you don't coordinate when things are going wrong, or when you're going to make a significant change, or even when you're just fiddling with a testing environment, the likelihood of breaking things is significantly increased. Communication needs work. There needs to be an open, honest, no-blame culture where people feel they can admit to their mistakes freely and talk about what happened without fear of repercussions. Our central production, our user help teams sit nearby to us, and we have open invite demos within the pipeline work so they can see what's coming up. And when there's a problem, we head over and we talk face-to-face with them. Never underestimate the power of email to skew meaning. And always remember the principle of the Agile Manifesto. The most efficient and effective method of conveying information to and within a development team is a face-to-face conversation. Does anyone remember the GitLab major meltdown? Yeah. This was a great example of open and honest communication, though, when things were going really, really wrong. For those of you that don't know, GitLab is or was a Git hosting service. It was similar to GitHub. Is. A developer accidentally removed most of their data from the production database. They lost 5,000 comments and 5,000 projects issues. But the way they handled themselves was a great example of good communication. A few of the developers jumped onto a public live stream to discuss the problem. This was fairly natural to them, I think, because they already worked remotely, but what they did was they made this public. They also had a completely public Google Doc with a timeline of events and things that they had tried. The community reacted so positively, sending love and hugs to the team, especially to team member one, the deleter of the database, who was never named, I don't think. It really shows how people appreciate transparency when things are going wrong. I've talked a bit about communication before code goes out the door and a little bit about when things are going wrong. But what about after the incident has been resolved? After all, those are the times when we can really learn what went wrong and why. At The Guardian, like many of you I'm sure, we have post-mortems or incident retrospectives the day after an incident. These are an open invite with mandatory attendance from the teams that maintain the system and the engineers that were on call or resolved the issue. These are the true what and why environment. They're free of finger pointing and they're laser focused on finding remediation tasks to shore up the tools and systems that didn't work as expected. So as the fire alarm was going off yesterday, Michael, during his talk, reminded us that retrospectives are about asking, how did the system allow this problem to occur and how do we fix it? They provide a short description of what happened, and then they pull together a timeline of events. When did the support devs get called? When did the monitoring notify the teams? When were communications sent out to affected users or statuses updated? Then there's questions that are raised. Why didn't an alarm go off? Why doesn't a section have unit test coverage? Why isn't something protected by the cache? These questions are designed to tease out the bullet points for the next section, the actions. Actions will often vary from investigations to answer the previous questions. Things like adding more health checks or alarms and checking that similar sections are covered. Also, we might add logging to make it easier to debug in the future. And we also want to make sure that systems are more robust. Things like catching exceptions or providing better fallbacks or failovers. This process is a virtuous cycle. Each incident retrospective teaches us how to build more robust, resilient systems that filter into the next product or feature that we build. Sometimes it can feel like a disaster when things are going wrong, but the majority of these issues go unnoticed by our users. So let me recap. We have pre-merge monitoring and testing. Linting and unit tests, we build pull requests and we deploy them and do thorough testing on that. We have lots of templates, so we run visual testing on the different formats. And make sure you've built a no-blame culture of autonomy and trust. We have post-deploy monitoring and testing. And alerting. Alert on symptoms and not causes. Use dashboards and graphing to get a shared understanding. And use front-end measurement tools to measure what your users are seeing. Build robust tools, but think about the critical situation testing. Build checks into tools to help users, and serve stale content if origin servers are erroring. And build excellent communication between your teams. It's important, so I'm going to say it again, have an honest, no-blame culture. Talk face-to-face, and have productive retrospectives with clear actions. By sticking to these pillars, we've ensured that when things do go wrong, we know, and we can fix them often before most of our readers notice a problem. Each thing that breaks improves the robustness of our tools, processes, and infrastructure. All in all, we're moving forward. We're building the tools, the checks, the processes, and the communications so we follow Facebook's new mantra. It's not quite as catchy, but it's certainly a better strategy for building websites and applications. Move fast with strong and stable infrastructure. Thank you very much.